final speaker of this session is Matt Day. Matt has worked at Garland Publishing, Biomed Central, and NPG before joining Wolfram Research, so he's had a variety of experience. And he's currently leading the development of a new approach to publishing academic research data with the goal of making it fully amenable to discovery, computational analysis, and reuse. His talk is Actionable Data, the Wolfram Approach, and he'll be doing a kind of live over the internet presentation, so please be forgiving, patient with any technical glitches. Matt.
Yes, thank you. Hopefully you won't have to be too patient. So it's really great to get a chance to talk now. I think that well, in fact, all of the previous talks I think are very relevant to some of the work we're doing and some of the issues we're tackling and the things we're interested in. So I want to talk really about kind of what is the nature of information facts and what can you do with them, what can a computer do with them, and how do people kind of work with those facts even when they're collecting them themselves or analysing their own information, publishing it, or finding and using other people's knowledge. So let me start by just giving a very quick introduction to Wolfram Research for those of you that don't know. So it's compared to IBM, for example, we're a very young organisation. We just had our 25th anniversary. For much of that time, it was about a piece of software called Mathematica, which is a computational engine. So it does maths, it solves equations, it does numerical analyses, it plots results. It's a rich platform that can do a lot of computational hard work. And in recent years, that's been extended to something that I'm going to show you next, Wolfram Alpha, which is where we've taken computation and added data, and so facts, if you like, and added knowledge, which in our terms means kind of we know what we can do with the facts, we know what kind of computations we can do with them, and combine that with natural language querying to create a knowledge engine. So very similar to, in overall vision, to IBM Watson. It's a human interacting with a computer, asking a question in English, and getting back an answer that probably doesn't exist, well, most usefully in cases where the answer doesn't exist anywhere. So Google won't be able to answer the question for you, for example. And I'm going to break my talk into two parts. One is I'm going to talk a bit about facts and what we can do with them in Wolfram Alpha. And then the other is what our technology can do with cases where we haven't trained the system to know really what to expect. It doesn't understand about the data that's been given. And I think this is most relevant to publishing, where people can output virtually anything really, and we want machines to be able to do something useful with that. So I'll talk about those two things, and I think over time that those distinctions will become blurred, but at the moment there is that distinction. And then I'll try to finish just quickly by giving you a flavour of some of the things that we've got coming up. So it's going to be a very busy couple of next year, and the year after that I think is going to be very busy for us in new product launches, which I think are going to hopefully make up what we're doing even more relevant to the publishing landscape. So Wolfram Alpha is essentially it's a consumer website. It's free. I'm logged in. Well, I should be logged in. For a few added, I need to log into the internet. Okay. Okay, so what is it about giving talks and things not working? Okay. So it's kind of, for some reason, I don't quite understand the tradition at Wolfram that we start with just the simplest of all questions, 1 + 1. So I've asked this question, I've just typed it in, and it's given me an answer. And it said, well, we'll give you the answer, but we'll also give you a bit of context around the answer. We would say that this is a report. It's a very simple query, so the report's simple, but you can see that we've given an answer and we've given a few things about it. We could give it much more complex maths questions, and a lot of our users are just simply using Wolfram Alpha to answer maths questions, maths homework. but we can then, so a slightly more sophisticated question is, say, what's the GDP of the UK divided by Italy? And you'll see that my typing is just wonderful. Okay. So this is also a very simple question. To answer it, the system has to understand about, obviously, country names. It has to understand about GDP as an abbreviation. It has to have GDP data for these countries, and the system has to know that those data are in different currencies and how to convert the currencies. And so once again, it's given me an answer. It's done the currency conversions, and it said, well, given that question, it's a simple question. The person might well be interested in a historical chart as well, so we'll give that to the user. And all of this is calculated on the fly, so it's not just like a canned answer. And I'm pretty sure that that historical chart is also calculated using historical currency exchange rates as well. So now the system is starting to be a bit more sophisticated in interpreting the question and giving you something that requires a little bit more effort on its part. And there's all sorts of data in Wolfram Alpha. So someone pointed out to me recently, it's kind of silly, but we've got goats in Spain. Divided by, well, let's try, so this may not work. Okay, so I knew that Wolfram Alpha knows that the Big Apple is how people refer to New York, and I'm glad that it's figured it out in this case. So now we're combining different numbers. It's a nonsensical thing, but it's essentially that the system is parsing and trying to interpret what the question is. And we could ask a question about apples, for example. So we could say like 2.5. So we could ask a kind of a foodie type question, and it's interpreting now apples as being what we expect, apple juice. So the system is very smart, and it's giving answers to natural language questions using information and language parsing. And some people use this in all sorts of ways. So one example I heard recently was someone who planned proposing to his girlfriend he wanted to do it in a romantic way, so he picked a venue and he wanted it by the sea, and he wanted the time of the sunset at that venue so he could time, everything to coincide with the sunset. So Wolfram Alpha knows about this. It knows about the Earth as an object. It knows about time zones. It knows about the sun. And it can calculate sunset times. It has a lot of real-world knowledge that it can use to answer questions. So I'm not just going to give you a kind of a slightly tortuous tour through the domains of knowledge that the system knows about, but there's a lot. So there's a lot of maths and statistics. It understands a lot about units and measures, but it also understands about people and culture. So we've got a lot of social science and economic data. There's sports data. It's very rich, and just really a pretty large amount of data backing up all of this. Combined with, so it's facts that the system knows about what those facts are, and also what it can do with those facts. Okay. So I've given you some fairly trivial examples. We could go to some more complex ones, but I think you get the general idea. Our technology also allows you just to throw anything at the system. So here's a bunch of data. What can you tell me about it? So here's a file that I created. So if I show you. Okay, well, if that's going to be slow. Okay, so I went to the Web of Science and I just pulled out journal citation impact factors. So I've got a list of ISI subject categories and numbers of journals in those categories and numbers of articles they publish and various impact factor metrics. And then I've gone through and I've categorized those journals by whether by those subject categories, about whether they're clinical or social science or medical. So I've got these two layers of categories: medical science, social science, and then within those For example, science, we've got chemistry, biology, so subcategories. So this was just started out life as an Excel spreadsheet, some text and numbers, random stuff. And then we load that into the system, so we have an upload. I won't show you, but it's basically you just upload files, and then you can upload images and data files and all sorts of things and store them. So I've just uploaded it and stored it, and I've given it. I've just hit equal. So I said, what can you tell me about this data? So it gives me a slightly not entirely user-friendly preview, but it's said, well, you've got a load of columns of numbers, so it's going to plot those columns. That's not very useful in this case because there's no order to the numbers, but it's done the obvious thing, and it's compared some of the columns against each other. Again, in this case, it's not particularly useful. It's figured out that some of those columns have got words that just keep reappearing. So it's figured that they're labels. So now it's given me some statistics about the frequency of the labels. So now I'm starting to get a sense about the range of information in that data file. And if it was huge, that could be very useful. Given the fact that it's recognized loads of numbers, it says, well, I'll do correlations of all against all. So this is kind of useful. You can see that things that you'd expect to correlate with each other, like different measures of impact factors correlate. But other things, like the number of journals in the subject area, doesn't really correlate particularly well with the aggregated impact factor. So you start to get very quick senses of the range of how the data columns relate to each other. And then it's given me, the biggest number, the smallest number, the median number, how many numbers there are, basic statistics that it's generating quickly. And it's also it's figuring out what are appropriate statistical tests given the data, and then running those tests and then giving me an output in English. So it's telling me that certain things appear to be correlated. And every time I do this, it does it in a different way. So it's doing it in a few ways here, but it's telling me that some things aren't significantly correlated. And then if I really want to, I can go into more depth and see some of the details about the correlation factors and things like that. So the point I want to make here is that this system can be very smart about receiving data, figuring out what kind of data it is, and doing something appropriate with it. So here it's kind of numbers, but we could do something very we could say London. So we could just give it a few place names. And that's kind of embarrassing. Well, I'm not going to bother about that. Yeah, so it should have done this. So potentially it could be a very big, long list of places, isn't it? Where it says, well, now I recognize that these are place names. It's given me some basic facts. Given that they're place names, I can plot them on a map. So the system tunes what it does depending on what type of information you've given it. Just very quickly, I want to talk about how things can be output. So we have a technology called CDF. It's basically just a file format, and we have free plugins for people just to download so that they can view content. And what it does is it allows people to create things that they can then share with other people. So some of the output that you saw in my Wolfram Alpha queries are essentially creating CDF output. But people can create their own CDF files and share them. So this is a really simple example. It's the person that created this, I bet you, did this in very few lines of code, because the system knows about the world as a slightly squashed sphere with where the country outlines are. It knows about how to calculate distances. So it's very easy for someone to create an interactive widget to show you the shortest path between two places. And this CDF technology can be used in slightly more sophisticated ways. So one of our biggest fans, I guess, is this lawyer economist uses CDF to show complex models in an interactive way in reports and in his teaching as well, where you're interacting with quite sophisticated analyses, and the user, may want to fiddle around and see something, and also get a feel for what's the modelling behind this is really showing. So very quick and easy ways to create interactive, user-friendly widgets that can be powered by highly sophisticated world knowledge that the system has, that the user doesn't need to worry about. So just one other example quickly is this kind of infographic type thing where we've got various panels and you can see different types of information, and some of these are simulations that you can run. It's all a rich kind of user interactivity where someone that knows nothing about a technology can very quickly come along and play around with it. And it's also easy for the people that create this, fairly easy for the people that create this, to do this once they have their information, their facts put together in the first place. So the general message is, if you've got data that's in a particular form and we teach our system to know about it, it becomes very powerful and very alive. And it's very easy for people to take what we have, our technology, the facts or their own facts, combine it with their technology and to produce things that are very kind of accessible to other people. Where we're going with this in the future is, and really stuff that we're working on at the moment that's going to be released in the coming year or two, is really we're faced with a world where there's a lot more data, there's a lot more variety. We need to bring computation and data together, and we need to create systems where almost anybody can get something really useful out of that, so they can find information and then they can understand it and interact with it. So it's about bringing together data and computation together in a cloud environment where someone can just go with a web browser and play around with it and see it and discover it. It's about making it incredibly easy to create things that can be shared, can be published for a wide variety of different types of users. And it's about making it easy as possible to do things like create automated reports, so just kind of snapshots of data that's dynamic, huge inflows of data from maybe into a whole load of devices that are connected to the internet that are feeding into a centralized data repository that's then kind of chewing over that data in real time and periodically generating snapshots or reports. So it's about the computation, but also making it really accessible and useful to a wide range of people. And I think the long-range goal really for our organization is that if a question can be answered on the basis of human knowledge, then a computer should be able to do it. So very much what IBM Watson is aiming towards. And to make that really work in the future, we need to find as many ways as possible for people that have data, to have information, to, without being experts or even have any knowledge of how our systems work, to be able to put that data into a form where our analytics and our question answer systems can do something really useful with it. So that's a somewhat hurried kind of rundown, but I hope you get a general flavour of what we're working on and what we've got already, and just the power and the range of what we can do. And hopefully you can see that we don't need to do too much more to make it very easy for academic research to be published in a way that's very actionable, very easy for people to do something with it that can have very powerful results. Thank you.
Fred Dilla, AIP. Very powerful, very interesting tool. Can I ask you what your business model is to pay for all this?
There's several layers. The Wolfram Alpha Pro, which is where you get to upload your own data and stuff like that, is paid for. It's very cheap, but that's a business model. The main heart of it is actually custom Wolfram Alphas. At the moment, the main business is customized Wolfram Alphas for organizations where we just empty Wolfram Alpha of some or all of its data and train it up for a client's own data and give them an internal tool, generally internal. Sometimes it can be powering a public website that's not so obvious. For example, Siri, Apple's Siri uses Wolfram Alpha to answer a lot of the kind of factual-based questions. So that's really So we've got custom Wolfram Alphas, and we've got the Wolfram Alpha API as typified by Apple Siri.
Hi, quick question. It seems like a lot of these data services rely a lot on interfaces. You have the speech recognition, you have graphical interfaces. How much of your time is spent developing and refining interfaces?
Yeah, so a lot, and increasingly so as well. So some of the new products that we've got need user interfaces. For example, what we call data science, so how someone works with potentially very large complex data and doing very sophisticated analyses, but without wanting to be a programming language type user. That's a complex user interface question that we're working on as one example.
Other questions?
What's your approach to data curation? Just having it might just be the mobile site, but there's information there that I'd love to know where it came from and what to do if it's wrong.
Yeah, so Wolfram Alpha, the team takes in data sets and does a lot of work on them, and there's a slightly unsatisfactory citation system in Wolfram Alpha for historical reasons that's being improved, but they take in data sets and work with them a lot. A big part of the new work, in fact, the stuff that I'm particularly involved in is making it easy for people to bring in their own data sets and very quickly bring them into contact with our kind of technology, and also to make it easier for us to go out and take interesting data sets and combine it into Wolfram Alpha. So the data curation is a couple of tiers, really. One is the most sophisticated data curation is the semantic kind of processing and that goes on for Wolfram Alpha. But then we're working on new technology to make it as easy as possible to bring in other kind of random data and semantically enrich it and make it computationally useful.
Okay, well, I think we probably should switch over to the next session then, but thanks
Okay,
again, Matt.
thank you.
Thanks to the rest of the